Aloha, Richard Halverson here. This is ICS211, and today I'm going to talk about Chapter 12, exceptions. So let me share my screen. And we are here, ICS211, and we're going to look at exceptions. Let's just take a quick peek at the syllabus and expand. So I'm talking about here. And so I'm going to see how far I get today. There's two Xylabs. Let's go look at the textbook. And chapter 12. So an exception is an unexpected incident that stops the normal execution of a program. For example, dividing by 0 or getting invalid input results can cause an exception. And if exceptions are not handled, then the program ends execution. So in this little example here, you're trying to read in a floating point number, and the person types in TWENTY, and that's a input mismatch exception because it's looking for a floating point number, and it gets a string. And so since this exception is not handled in any way, then it just causes the program to stop and output some stuff about what caused it to stop. And so make sure you go through these examples so you understand what's going on. Here's how you can catching exceptions. To catch exceptions, we use a try-catch block. And so the code that could possibly cause the exception is put in the try block. And then you have this catch part. There's a try part and a catch part. And you have this catch part, which will catch the exception before it causes the program to terminate. It catches the exception, and then it does its thing, and then the program doesn't terminate it. It continues. So it ends normally. It's just that it doesn't execute any of the code after or in the try block after the exception occurred. So here's an so go through these examples to make sure you understand how this works. A program may be able to resolve some exceptions. For example, here you're trying to read in a floating point number, and the person is fooling around and types something else, and it doesn't make sense, and so the exception is caught. But what you can do is, this is inside of a while loop, and it loops until it gets an input that it can handle, and once it gets an input that it can handle, this takes on a value. It calculates this light travel time, and then it sets this variable here equal to false. So when it loops back around, it's going to be false, and it'll quit. But it'll loop until the user types in a number that can be accepted as a floating point number. And in Java, you can type this in for a floating point number, and it'll ignore the commas, and it'll work. So and what this does, when the exception occurs, the exception it looks at this thing, decides that it's not what it's looking for, and then that causes the exception. The problem is this thing still sits there. Okay, so so you actually have to skip to the next line. So that's why you have to have something like this in there. This didn't work, so do this, and all this does is read the line, and it doesn't do anything with it. just reads it and doesn't do anything with it. You could read it and print it out and say, please enter a number or something. But since this didn't work, it still needs to be processed. And so that's why you have this here. That's why you cannot get by with not putting anything here, because the problem is when this fails, this hasn't been consumed yet. The line hasn't been totally sucked up by the program, and it's still sitting on that line, so it can cause an infinite loop. You can try it. You can take this, copy it into Eclipse, comment it, put a comment line there, and see that it goes into a tight loop. Anyway, this is kind of an interesting exercise here. It's not a bad idea to do this, but basically you are dragging over the code to make this thing be correct. And what this is it's a max occupancy tracker, and it's you enter in numbers separated by spaces, and whenever you enter in a positive number, it increments a count. Whenever you enter a negative number, it decrements that count. If the count ever reaches 10, then it prints out a message that says we're full. But if you enter in something that's not a number, then it just ignores it and goes and asks for the next number. And so you can fill this in by, let's see, you can go like, you're going to put a try in here. Where's the try going to go? I think the try is going to go inside the while loop. We can move it over. And inside the while loop, you're going to read this one. You're going to read in the next number. And you're going to, let's see, where are the rest of the, you're going to have this one. Oh, no, you're not going to, no, you're not going to do that. You're going to do this one. This will read in. What happened to it? What happened to it? Oh. We have the try here. What happened to the, let me load the default template again. Let's see, we're going to put a try inside here, and we're going to put a read this one, read it, and you're going to have this check here. If total number of people is less than 0, you're going to want to just set it equal to 0. And you're going to have a catch. Where do we test if it's, here we test to see if the total number of people, as long as the total number of people is less than the max number of people, it'll continue to read. It'll set it to 0 here. We have to have a catch part. Let's put that here. And we have to, if we have a catch part, then we just want to skip. We just want to skip that input and throw one of these over here. Okay, so we have try that as 0. If there's something wrong with the input here, we're just going to skip it and keep the loop and let's see what this, oh, actually, let's see, total number. Where do we put that out? Where do we put that? Each time, after each input, it outputs a total number of people. Okay, so we gotta go, this has gotta go above the catch. Yes. Oh, there's gotta be an end to the try, doesn't there, right here? Oop. Man, this is bad. All right, let's see what this is. Got some leftover stuff here. Check. Oh, good. So anyway, that's a good exercise. Good exercise for you to do. Here are some common exception types. You reach the end of a file. You reach the end of file when you're reading a file. Input type mismatch. You want to read a floating point number and you get a character string. You're looping through an array and your index goes out of bounds. You try to open up a file. It's not there. It doesn't exist. You got the name wrong or something. And an arithmetic exception, like when you're dividing by 0, for example. Here's a challenge activity exception handling. Let's see. Let's start this. You should go through these. Can I? Oh, I can. Since this is a you can't do this, but I can do this, and I'm just gonna you can do the first one, I'll do the second one, and you do the third one. Okay, this is the second one. Okay, so we're supposed to do the output. Okay, so there's a class, power resistor exception handling, electrical engineering stuff, scanner. We have a integer of current, which would be amperes, integer resistors, which would be ohms. Resistor ohms equals 1. Anyway, so you have you read in a current, you calculate the power, which is current times currents times ohms. Amps times ohms is power, it's watts. And this prints it out, and the input is 2.1. And but you're trying to read in an integer, so that's a problem. So it's going to cause an exception, and this is what the it's going to come to here. It's input mismatch. Then you can do a print line. It's going to be error getting input. Enter. I think that's all it's going to do. Let's see if this is right. Oh yeah. Okay. You can do the rest of them. All right. So now you can throw exceptions. Okay, there's it's kind of like you can define exceptions and then you can throw exceptions. So let's say you want to have like some user-defined exception, like some input is out of range because of the just the context of the program, and it's not out of range as far as the definition of an integer goes, but it's out of range because they're asking the person's weight, and somebody enters in 3,000, that's obviously out of range. And so you want to throw an exception because you're not expecting the person to do that, but let's say the person just does do it. You may want to handle it as an exception instead of actually having a check for it in your after the value has been input. So this is how you can do it. Here, for example, throwing exceptions with a throw statement. Okay, so here you have a try, and here you're doing this calculation where figuring out what the ratio is. So you're dividing the volume of gas by the volume of oil. And it's if the volume of oil is 0, then since these are floating point, well, you can test here using this is not a number test, a double. If this is not a number interpreted as a type double, which is a floating point number, then throw this exception. And there's no name to it, but you throw it, and then that's going to cause this code down here to execute. And you can click on this and click through it and see that works. And so make sure you understand that. Here's some questions about it. Here's another one where this is separate error checking, using exceptions to do error checking. And it's kind of a convenient way to do error checking, because you can sort of consolidate all the error checking code into one section, and that would be in the catch of a try catch. So and you can have multiple exception handlers to handle different kinds of exceptions. Here's an example of where you're reading something in, and the first thing you're going to check for is specifically up here is a type mismatch error, an input mismatch error. It's common error, and so this is the catch routine for that. And then down here, this catches all the rest of the exceptions. So all the rest of the kinds of exceptions, this thing will catch every one of them, and you'll print out a message here. And so you want to have the more specific ones first, and then at the very end, you can have something that catches all the rest of the exceptions. So that's what this is. Make sure you understand that. Here's an example of multiple exception handlers. We are if the person enters in a weight that is negative, then it throws an exception called and it's just throws an exception, and the message is going to be invalid weight. Here, somebody enters in somebody enters in a negative height, that's invalid. And then here you can actually have something where you get something where you can't calculate. Where's a plain old exception here? Well, anyway, so if there's an exception and this isn't it, then this executes. So anyway, that's you can go through here. Here's another one of these interesting exercises where you drag the statements over, and so you do that. Make sure you get the participation points for that. All right, exceptions with files. This is pretty important stuff here. These are the different kinds of you're going to have these kinds of. I'm going to include these classes, part of scanner, that goes along with scanner, and these are the different kinds of exceptions that can happen with files. When you're dealing with files, make sure you understand these. Closing files, and we went through there aren't any more challenge activities. Here's catching the different kinds of errors. Let's see. You can go through these, make sure you understand these. It's you can combine the opening or creating the instance of the scanner object to be able to read the input with the try. And so with the try, this executes. Let's go up here and see it. With the try, this executes. And if this is successful, then this executes. What's nice about this is, which we're going to introduce next, is the finally block. So if you do it this way, this thing opens up, and either this executes fully or this executes fully. either way you want to execute this finally part here, this should be file writer, it should be an R there, which will close the file or close the input, the file input. It's this program here, so this should be writer. So you can complete the data. Okay. So anyway, make sure you understand that. Now, when you're using methods, when you're using exceptions with methods, an exception could be caused, an exception could be thrown, like down in some method. A method calls a method calls a method, and then there's an exception down there. And that method way down there might not handle it. It may leave the handling of the exception to to its caller, or maybe its caller's caller. And the way you do that, the way you can do that is when you have a method, when you have a method that can throw an exception but does not handle the exception, then up here in the declaration, you have to put this throws exception to tell this is to tell the caller that I may throw this exception down here and I'm not going to handle it, so you have to handle it. And so here we see how that works. The method is get area, and so down here circle radius get area. So this method is called here. It's called, and if this exception is thrown, then it's going to be handled out here in the caller. This is the caller. This is the caller, and here's the catch exception. And so if this exception is thrown inside the method, then it's going to be handled out here. So the exception throws the exception, the thing automatically exits and comes right out here. So you have to have this in here to tell this method that or to tell the main program that when you call this this exception, it may throw this exception, and it's got to be handled out here. Okay, so anyway, that's how that works. So make sure you understand all this. Java's catch for specifier requirements. That's requirement. That's what I was talking about. So make sure you understand this. It's kind of intricate to what they're explaining here. I'll just confuse you if I go into any detail. So make sure you understand this. Okay, here's user-defined exceptions, and we did introduce user-defined exceptions with just this exception class, where you can just say, you can just throw this new exception here. I'm going to throw this exception because I don't like something that happened, and this is the message that displays out. Okay. Now, sometimes you may have many different kinds of these kinds of exceptions, and you actually want to separate them and keep track of them and have different exception handlers for different specific user-defined ones. See, this is all going to go to one exception handler, and that's this. You may want to have different types of user-defined exceptions which go to different exception handlers. And the way you do that is you create your exception, you create a class that extends the exception class, and you can define it there. And so once it's defined there, then you can have a catch, a catch that addresses it specifically. So here, for example, we are defining an exception called invalid negative input exception. And we're going to define another exception called NaN exception, not a number exception. And then we're going to have this code here, and here we're using the not a number exception. We're throwing this exception, and here in this one here we're throwing a different kind of exception, and they're all handled by the main program. See, we have this throws there, which says, density calculator says, I may throw this exception, and if I do, I'm not going to handle it. The caller, you have to handle it. And same with here, this get density may cause this exception, and yeah, so I notice they're both here. That's because anyway. All right, so anyway, you can have so we have separate catch exception handlers for each of the different user-defined exceptions. All right, so make sure you understand all that. And here's a nice example. Let's go through this example. Let's click through it. And I don't think there's any participation activities in here, but this is if you're kind of rusty on your understanding, see, it gives us a solution here. Here we're can run this, and the error has to do with you want an integer, and it's giving you a double or a floating point number. So this shows you where to put in the try catch for that. See, this is the error, and when you run it with the try catch in there, it'll just display out this error and continue on. All right, here's the first lab with, how far are we? 27 minutes. All right, I tell you what, I think I'm going to close this video out, and I'm going to start a new one and do the lab. All right, thanks for watching.